Alrighty guys, I'm back out here in the shop with my little one Anna. My goal today is to tear apart the transmission as far as we can, but I'm also going to, before we get into that, I'm going to show you some of the 3D printed copper tooling and one of the intake manifolds, so let's get right into it. Okay, so this is a 1.5 inch coupler. It's got like a 41.5 millimeter internal diameter. So this is the top side of the intakes, but it's close enough, easy to see. So if we line that up with that edge there, and we move it across, you can see there's definitely some size difference there. So we need to get a press tool to press this guy to a 42 or 42.5, I think it is. So I don't have one of those. I did print this, and if you've been paying attention to how I make these things, you'll notice a critical flaw. I'm not quite sure how I did it, but I accidentally made the angle on the slide out pieces the wrong direction, so that sucks. So this thing is almost all worthless except for the retaining ring, I call it, and then I guess the center pin could be reused. I probably won't reuse it though, because I made it slightly undersized and it's just a little bit too loose, so I don't like that. So a couple things going on here. I took a unheat treated piece and I attempted to press it onto the original small tool, and it shaved off the side, so that didn't help. So I did two things. With this new guy, I went and chamfered that leading inside edge. Yeah, this one's knotted, it's on this side. So I chamfered it so it'll slide on a little easier. Yep. And we're still going to heat treat, so that should help. I'm hoping the larger we go doesn't necessarily make it much more difficult. I mean, the wall thickness is a little bit thicker. It's not that much thicker. I don't have my calipers out here, otherwise we'd measure it. So that's where we're at here. It kind of sucks, but I got to reprint 4 to 5 of these components. I'm also, oh yeah, you know what, I got to print the center too. I'm going to make this center rod piece and center hole much bigger to fit these guys, right? If I slide this into the middle, it's not guaranteed to fit in the hole like that guy was. So yeah, that sucks, but it's 3D printing, so it's, you know, this costs maybe $50, maybe $25, something like that in terms of plastic weight. So that's that. That's where I'm at for these guys. I'm kind of trying to do stuff in parallel as I can. So let's take apart that transmission. We have a whole bunch of 12 and 14 millimeter wrenches, or nuts and bolts. And oh, something I did notice, I've been thinking about this rod. So there's some shifter selector paddle things in the inside in here, right? So, and that little click clack back and forth you're hearing is some of the lash between the paddles there, right? So if I go and move this selector all the way to the side, do you see how this guy drops on its own? And you can hear it's not engaging any of those paddles in there, right? So I think that if you shift this rod all the way to the side, this thing stops engaging the paddles, and I think if we do that, I think we can slide it out. I also noticed on the back side of this, there's this embossment here, and it's machined down, and it lines up against this guy. So, hang on here. So the travel of this lever is going to be limited by that machined surface, right? That's a specific height offset from there, right? Or on the outside of the gasket, basically. So that's going to talk to that dimension and can prevent this thing from not engaging the paddles, right? So there's your 3/4, and if I gently, right, I don't have the limiter, so I don't quite know how much. There's my 1/2, right? But if I go even further, then it engages nothing. So I think we need to leave this here, and then I think we can drive it off. Yeah, otherwise, I think the way to do it would be to drive the pin out to release this guy, and then undo that pin and slide that rod out so that the whole thing can slide. So I'm trying to avoid that. I think this will be the ticket. What we'll do is, while we're tapping this guy out, I don't think I'll be able to film this on camera, but I'm just going to have to be watching for motion on this rod to see if it's if it's being caught by anything. So I might need to like tie this guy off so that it holds. We'll just see how it goes. All right, let's get to it. Okay, so there's a few things worth mentioning. We got these nice big long taper pins, but just keep in mind this is how far you gotta knock this thing to get it home. There's another taper pin under there. I think it's just those two taper pins. Yeah, this is the same one here. That's the same taper pin there. Okay, so as far as strategy goes, I'm probably going to be trying and tapping from here with a dead blow mallet. And I noticed that there's also a good tappable surface back here on those two. I don't know if I'll take the shifter off, the shifter bracket thingy off. We'll probably take that off. Let's see, what else was it? Oh yeah, the two long bolts here. This one's kind of self-explanatory, but we'll make a record of it. So the longer one goes up high, and you can just put this thing up against the seating surface and see where it goes into that embossment back there, right? The shorter guy, not going to make it all the way, so make sure, remember to put the shorter guy down here. In addition to that, this guy had this bracket right there. I don't know what this bracket is for, but that's where that one goes. So let's tie this guy off and start hitting this thing. Okay, so I wanted to record this just to give you an idea of how hard you gotta hit this thing. So I've been hitting it a bit, and I've got a tiny gap, probably barely a fingernail width. So I've been having good luck with hitting here and hitting back here on the shifter bracket embossment thingy. So let's give it a whirl. That's a thumbnail fingernail width. So let's flip her over. Oh, there she goes. Oh, there goes that. Nice. Got a bunch of oil coming out. I tried to angle this thing at every single angle I could think of to get the oil to drain. Alright, let's show you where we're at. So, got a decent gap now. We tied off the shifter. Still loose. Let's see, can we see it in there? So far, I'm not seeing that thing. It's not really possible. The position of the flash relative to the camera lens. Here, let's bring the other light. Oops, sorry. I'm not seeing it, so far maybe we're okay. Alright, so I think from here it'll be pretty easy. So I'll start recording in case there's anything tricky with that shifter assembly. Oh man, we got it open. So good news, using a little bit of baling wire right there on the shifter assembly worked great. These are the two, I think you call them gates, where the end of that shift rod chills. Look at that. Okay, so great news. I love that that worked. You have to hold the thing up while you're breaking it free. Once this thing was broke free, that initial like 1/4 inch, it was really gentle tapping. So you just got to go back and forth, one side after the other, and just gently bring her off. Once this guy was loose, though, this thing just popped free. So I can't believe it's finally coming apart. Ooh, there you go. You can see synchros. That's pretty neat, huh? So, yeah, we're gonna have to go get the laptop and watch some of the 5-speed teardown videos to get a better idea of what our next step is. I think our next step is to undo that guy and maybe that one, I think. Let me move that. I want to see what the end of the shifter selector looks like. Ah, interesting. Oh, what is that guy? That looks like some kind of seal. I don't know what that is. There's this thing. This has that really weird little torques with that thing in the center. I don't remember what they call those specifically. That guy acts on that. And I'm thinking that's some kind of positioner. Where does that line up? Let's see that one. So this guy's a little, had to set this guy on a piece of wood so the weight wasn't on that. That's easy enough. I'm wondering if that guy limits that or something like that. We'll look at that a little more later. Okay, so got all the through bolts out. These two, the dark ones, are from the backside here. This is the retainer for the bottom shaft or whatever you call it. You gotta take this guy out. This guy's got a flat side and a step side. The step side sits in here. This is like a retainer for the top shaft. So that guy just slides out. That's easy enough. Set that there. And we're gonna, so following along from the 5-speed video, we're gonna try and do the same thing. We're gonna try and remove just this side. So I took those two, but I did not take those two. And I didn't touch any of this. One thing to note, and don't take those ones yet. You don't need to do that yet. Got to take the slave cylinder off for the clutch. And then we're going to tip back over here. These guys, I don't know what they're for. These are not through bolts. These do not have a matching bolt on the other side. And so, okay, the easiest way to tell is you look for the thread sticking through the end of the nut, right? So these guys are definitely bolts. Those are not going all the way through. So I don't want to mess with those because I don't know what they are. Those are probably some kind of retainer system for the shifters. So don't want to fool with that. So we're going to try, just like the 5-speed video, we're going to be hitting here, there, on the inside, not hitting the corner edge of the surface. Maybe we'll go for that embossment. And then on the underside, there's this guy on the side of the split. And then there's also that one on the side of the split as well. So there's a good amount of spots to hammer from. So we'll, oh, you know what? That can probably stay. Doesn't hurt to take it out. Take that out too. So we'll go from there. I'll update you if there's anything to see. Alrighty, so I brought my neighbor over to help take a look at this and film a little bit. So this thing split off. It took a good amount of strikes with the hammer, but it wasn't infeasible. So this 2014, I think it was an Outback mom car, so no limited slip, center diff, so that pretty much garbage. One thing I noticed that I put it away. One thing I noticed on the new locking diff, it doesn't have bearings on it. I'm probably going to go see if I can source some new ones. These have a little bit of movement in them, probably an acceptable amount, but if I can get a new bearing and not have to try and pry that one off, I think I'll go that route. However, I think we can reuse this center diff for the clearancing work on this side of the transmission. So, one thing that I haven't seen before is this little oil deflection plate deal. It's a little thin piece of sheet metal. So it's got this little slot right there, and that's where the gasket is on the other side, but there's no matched slot here. So this guy, I'm assuming, is junk, so I don't think we have a use for it. As far as what it does, I don't really know what the purpose of this guy is, but yeah, definitely not a reversible part, so you can only assume we trash it, right? I don't think this thing would clear the gear set. There's no way that pinion gear, when it's flipped, is going to clear, so I think that's garbage. What else did we see? Oh yeah, this thing's going to wobble all over in here because it's not retained by that side. So we still haven't done the other two bolts on that other side, so we're not pulling the shaft just yet. I wanted to show the way the shifter mechanism stuff works. So let me switch sides here. So this guy up in here, see the reverse cut on these gears? That's the reverse gear. Now if you grab the shifter down here, pull that way, that engages reverse. And if you watch over here, you can see how slow it's spinning, right? And then I also figured out that this guy should be first gear. Second gear, a little bit faster, should be third gear, fourth gear. And then this guy going in, that's fifth. Pull it all the way out, there's sixth. So that thing's spinning a lot faster. Now, what else is there to show? Oh yeah, if you're gonna fiddle with these, you kind of gotta finesse the thing to get them to pull all the way through. So there's neutral, and you can see it's not spinning output shafts. This guy's free spinning until we bring the lock nut in and lock these two shafts together. Oh yeah, this guy, the drain plug, it's a T70, and I don't know why on my car, but this thing was in there good. Impact didn't bring it out. I had to go get a breaker bar, and like a 2-foot breaker bar on top of the, it was ridiculous. So that was not fun. But yeah, get the T70. Don't try to make a 60 work. It doesn't work. Ask me how I know. So this side here is the side we're going to clearance. So once we pull the lower gear set out, we're going to pull this guy out, and we're going to set it in the race here. And this one here is the main one that we're going to have to clearance first. So this ring gear is threaded on the other end, and there's some through bolts going through the differential. And the heads of the bolts are what's going to be impacting the ribbing here. So we're going to have to clearance that. But first things first, we're going to have to pull apart the shafts. One thing to note, so this guy right there, that's the spacer shim, whatever you call it. So you add or remove thickness in the shims to bring the pinion gear in and out on the ring gear. And we'll use the yellow gear marking compound to judge the engagement pattern and shift the pinion gear in and out. And then also on the back side here, use the special Subaru gears tool to twist this guy in and out. One thing that we can't forget as well, the oil seals are directional. It might be, you might be able to see, but these guys have little angles on them. And yeah, so they're directional. You have to flip them around. So if you don't flip them around, the oil will actually be driven out by the direction that the shafts turn. So you gotta flip those to the other side. So before we go do that, I'll go watch the 5-speed video and verify that I'm pressing those out correctly. I don't want to damage them. I don't think it's in the 5-speed videos. They don't go buy a new seal, so hopefully we can take care of that and not break it. It may, in theory, be possible to slide this upper shaft out, but there's no reason to. I don't actually know if the shifters will let it slide out. I think it has to, but I'm not going to mess with that. While we're here, we'll real quick go and get a measurement of all the thicknesses of the gears. Let's see here. Let's make sure this guy's good and clean. Get a good 0. Okay. So we're measuring in millimeters. We'll convert back to inches if we need to. Ooh, this is going to be a tricky measurement. So that's about a 21 millimeter wide. This should be your first gear. Let's go to, well, I don't think we're going to be able to get those guys. Try over here. Get second gear. Looks like probably about a 17.9. Can we even get in here? I don't think we're going to be able to get the third gear anyway we go. I don't think I can get, no, can't get in there. Can't get the third gear. Third gear is usually the one that shreds on the 5 speeds. I suppose we could just kind of eyeball it here. Let's go. There we go. Need more hands. Okay. Try to go there. It looks, maybe it's a 16 millimeter. Maybe not. Maybe it's a 15 and 3/4, something like that. When we pull this out, I don't think we're going to be able to get in there. Well, anyway, moving on. Let's look at fourth gear. Alright, fourth gear, what's that, a 15.08. That's a fifth gear, another tricky one to get at. Oh geez, try the upper one. I think these guys are going to be the same thickness in all of them, right? They all look like it. So that's a 16.5, and then there's sixth gear, that's a 17.3. So we'll go look at the 5-speed gear set widths. I'll put a little chart together and we can compare and see what the differences are. Okay, so I gotta interrupt this video and kind of describe what I thought I remembered and where I was wrong. So I thought I remembered what I saw on the web was the thickness of each individual gear. And the website I found that I thought I remembered, it was talking about the thickness of the base of each tooth. So I just attempted to go and take the same measurements. I was going to measure 1 through 6, but I have no idea how this guy measured that. You can't get a set of calipers all the way down to the base of the valley because the calipers are too wide. Maybe you can find specialty calipers to do that. You can't come in and align with the correct angle of the helical. And if you try to, see right there, I'm straight and up. Right there, I'm basically in line with this one tooth, but I can't get the caliper in. So if I want to get the caliper in, I got to come in at an angle like that. Well, that ain't right. And I can't. So do you use the very bottom of the? Sorry, it's hard to. Do you measure from the very tippy bottom of the valley? Do you measure from part way up? How do you measure that? So measuring the base of the teeth width, that doesn't make any sense to me. I mean, I understand that it's an important value, but the guy described using calipers to do it, so I don't know how the heck he did it. I don't see a way to measure that with calipers. I suppose it would be possible to eyeball the thing and put it bottom of the valley to the bottom of the valley, but I'm almost certain that's not what they did. So that's second gear. Here's third. If I do that, my eyeball is giving me a 5.8. Right? And I think the STI gear is like a 6.0 and the 5-speed's like a 5.03 or something like that. So if I measure in the bottom of the valley to the other bottom of the valley, this thing's almost an STI gear. I don't know if that's right. I have no idea how this guy measured that. It's very frustrating. So I understand that the teeth width is important, but to me the gear width is something you can actually measure and is more important. So if somebody that does a 5-speed build wants to go and get the data and throw it in next to my chart, that would be great. Yeah, I guess that's it. So sorry for the interruption. We'll continue on with the transmission disassembly. So moving on from there, we'll go verify with the 5-speed disassembly video that Subaru Gears did and make sure we're taking the right steps. And I think the next step is undo those two and go from there. Alright, talk to you in a bit. Alright, so we went and made a mess here. So first things first, the drive shaft, whatever you want to call it, the shaft going to the motor, to the clutch, that one popped out no problem. It popped straight out of these. These guys must be only halfway around, so that's easy. The bottom shaft also popped out pretty easy. Just don't forget to undo those 2 bolts. Now, something very important that you can't forget, these guys have these little retaining dowels, and this guy is loose. I don't know if it'll, yeah, it will come out. Don't lose that. Will this one come out too? No. That one's stuck in there. Okay, don't lose that. So, where is it? The pinion shaft, there it is. Got to line up with that hole. This guy's got a hole on the other side, just like it. Once those are out, I brought this over to here. Even though I'm not using this diff, the interference is the bottom of the is this guy and then the bolt heads. So the main offender right now is this guy. That's your first one you cut, if I understand the process correctly. So you can fit check with this, and you can see right there. And that's your first thing you bump into. Now, something I saw to be careful with, just don't let this guy set to where the teeth would be rubbing the bearing race. So just make sure that's set in a good spot. So I just kind of wanted to see where we're at, if there was different webbing on the 6-speed. Here, let's go ahead and stick this in here. Yeah, we got a lot to remove to get that guy into there. So that'll be the first thing we start with. But before we get there, since I'm kind of following along with the 5-speed video, we're going to do the same type of thought exercise that Todd does, and we're going to check the pinion depth. Alrighty, so I just checked the pinion shim width. It's 0.060 millimeter, and I just had kind of a mini freak out because I was thinking, oh shoot, how the heck do you get a new one in? But it's split, don't worry. Thank goodness. So the shim and the plate are, I don't know if they're actually directional, but I'll tell you where mine was. So these bigger ears, which aren't present on the other side, the bigger ears were over here, up in that valley, oh sorry, that valley and that valley. So the bigger ears were on the original ring side, so on the shifter assembly side. So just keep that in mind. So now what we're going to do, so Todd in his video describes using a surface that you know is flat. In his video he used a piece of glass, so I'm going to use the drill press work surface. I don't know if I can do this one-handed. The way he describes it is this little stopper plate here. You loosen those and you slide that guy till it's at 0.5. So this guy, this wedged piece, slides further. So you need to loosen that and set it. So something that you need to watch for, you need to check, you need to look very closely at both surfaces. This guy has a nick that sticks up, so we need to take that down to the file. That's easy enough. I didn't notice any real, let me back it up a bit, any real surface imperfections on this guy, so that guy's good. So don't forget to check for that. So I'm going to clean that up. I'm going to set the tool height, loosen that, set it on the flat surface up there. Then we'll take this guy, we set it into the slot here, and there is no pin for that bearing that we need to worry about. However, we do need to line up these two dowel pins. One goes there, the other goes there. This one is one that was exposed to the elements, so it's a little dirty, so I might need to clean that out with a wire brush or something. So I will let you know what I found when I get there. Alrighty, so we got the pinion shaft into the opposite half, got it bolted tight, and we have the sight tool, or the pinion depth tool, into this side here. Now, something that I encountered and I didn't want to screw up, so this was my best guess at how to do this right. So this is a blind hole, and it does not pass through to the other side, or the other side there. This guy is a through hole. Now this guy didn't want to drive in a lot, the pin. It was encountering a whole lot of resistance, and I did not want to force it. However, the plate around it slid freely. I need to be able to get this pin out, otherwise that pin, right, you gotta have a hole. You can't have pins on both sides, right? So I left a tiny gap. So what I did is I took my calipers with the depth gauge tool, and I went and said, okay, that guy is 8-ish, 8.05, 810, something like that. So there's a little tiny gap. And I basically did my best to match these two sides at the same depth. Now, when I first checked this, I hadn't pounded this guy down to the 8 mark. I was way up higher, like 14 or something. And the end of this guy is not necessarily flush. So I think you need to get as close to the center of the pinion as possible. So I ended up with, what is that, 0.12, 0.2-ish, 0.15-ish, somewhere in there. So that's where I found it on mine. So once I pull this off, I'm going to go recheck this pinion depth on the bench press over there, or the drill press over there. And you can gently put this in a vise with a plate on the back of here, and one jaw of the vise on that surface and one jaw against the plate, and you can push this guy back to straight. So I already did that once. So that's where we're at here. So once we're done here, we're going to take this back over to there, and then we're probably going to start the clearancing work. We might actually do clearancing work on the next video. Okay, so I don't think I was clear enough when I described how to put this guy in the vise and push it back. So basically got a speed square aluminum plate. We're just barely giving it anything on the jaws. You can even just kind of bend this thing and it'll flex it back to where it needs to be. So that's kind of what I meant about trying to bring it back to flush. Okay, so the pin on the other end there decided to stay, and that's okay because we can drive this from the other side. Remember, this is a through hole. This guy is a blind hole. You can't get that pin out if it doesn't want to go. So I don't know if this thing will focus, but you can see the shiny mark on the top there. That's how deep the first pin went. Now this guy, it was protruding through on the back side. So I'm going to leave that there because we will need it for when we set the pinion depth with the new pinion shaft in place. So that's going to come at a later date. We're going to disassemble this lower shaft later. I think for next video we're going to start tearing apart the webbing and stuff and grind that stuff down and make the pinion or the ring gear and differential fit. Oh, one thing that really made me had me hung up for a while was the hole that needs to align with the pin on the bearing. Both of them were a little tricky. So the most important thing to do to help you get there is put a little mark on the side of the bearing where the hole is, because you can stick your head in here and you can see. And then the second thing was this guy can slide side to side, and I wasn't realizing that. I had this guy slid all the way to the side there. So what I do is I set it in place, and with my other hand here I can push down and it'll pivot up, and you just do a tiny little bit of pivot up so that this guy can spin free. This guy's already locked in, so I can't show you the full demo. But basically, you clock back and forth, and you can hear this little click, click, click as it's finding the pin. And when you find the center, then you go side to side and repeat until you hear a thunk, and it kind of drops in. So then you take your dead blow and lightly tap, send it home. Same process over here. This guy slides side to side as well as rotates. So mark it, makes it a lot easier. So I think that's it for today's video. We covered a whole lot of info, and I think on the next video we'll be starting the grinding procedure over there. So I'll see y'all next video. Oh, one other thing. Do your best to make sure the 1-3 shifter is in neutral, right? You need all of them in neutral in order to get this guy back into place. It's not the end of the world if you shift a gear. I mean, just so long as you play with this beforehand and you understand where 0 is or where neutral is, right? So you can do this kind of stuff. Here, let's see if we can find that, right? You just got to make sure you know how to come back to a neutral point, right? So you can just push these, right? It's not impossible to move these by hand, all of them. And then, of course, reverse. Don't do reverse. I don't know if you can reach in and get reverse. Anyway, so that's it. All right. See y'all in the next video.